Hello everybody. So here in this lecture, we are going to study the steps involved in predicting shape of molecule. Steps involved in predicting shape of molecule using VSEPR. Using VSEPR. Okay. So here, the first step in the determination of shape of molecule is to write the Levis dot structure. You can see here for methane, they have drawn the Levis dot structure. Okay. Then find out the number of bond pair and the number of lone pair in the valence shell of the central atom. So carbon is a central atom, of which we have to find out number of lone pair of electron, number of bond pair of electron. Okay. When counting the number of bond pairs, treat multiple bonds as if they were single bond. Treat multiple bond as if they were single bond. Okay. And use the given table in the last lecture to predict the structure and shape of molecule based on the steric number and number of bond pair and number of lone pair. If you see here in the diagram given below, carbon has 4 bond pair of electron and no lone pair of electron. So if you go to the table which is given to you in the book and that's mentioned shown in the last lecture, so that molecule is a tetrahedral in shape. That is tetrahedral in shape. Here, in the case of ammonia, one lone pair is there and 3 bond pairs are there. So it is a pyramidal in shape. Pyramidal in shape. In case of water, there are 2 lone pair and 2 bond pairs. Hence, it is a V shape. Okay. And here, for hydrogen fluoride, if you see, there is only 1 bond pair and 3 lone pair. Hence, it is a linear structure. Okay. So this is how, by using the table, you can find out the shape of molecule. Okay. Now see, here, sulfur tetrachloride. If you see at the sulfur, see there are 4 bond pair and 1 lone pair. 4 bond pair and 1 lone pair. Okay. So, and the molecule is sulfur tetrachloride. So if you see over here, so chlorine atoms are at the equatorial. Okay. And the 1 lone pair is there. Okay. That shows more repulsion. Because as we have discussed, the lone pair bond pair repulsion is stronger than the bond pair repulsion. Okay, and hence the molecule shows trigonal bipyramidal structure. The molecule shows trigonal bipyramidal structure. How? See, this is what the trigonal structure. Okay, and one chlorine atom is above the plane, other chlorine atom is below the plane. Hence, it is a trigonal bipyramidal structure. Now, if you see in the case of PF3Cl2, so here 5 bond pairs are there. How many bond pairs are there? 5 bond pairs are there. And from the table, you can see it is a trigonal bipyramidal in shape. Okay, for this SF3 Cl2, the structure is again set. Okay, because there are 5 bond pairs. Phosphorus pentachloride. Okay, here are all bond pairs. Here in the case of a chlorine type fluoride, 2 lone pairs and 3 bond pairs are there. Okay, so you can go to the table in the if what is there. I mean, I'm just taking you back over there. 2 lone pair and 3 bond pair. 2 lone pair and 3 bond pair. You can see here 2 lone pair and 3 bond pair. See here. This is 3 bond pair and 2 lone pair. What is the shape? It's a bent T shape. Bent T shape. Okay, so the molecule is here now. Bent T shape. Okay, after drawing, you can see on the next page. Okay, and here xenon difluoride is there. 3 lone pair, 2 bond pair. Okay, see pentagonal bipyramidal. Here it is a T shape molecule. It's a T shape. Okay, and here it is a. So what is here? In this case, I'm just taking you back to the table so that you will get more acquainted with the table, which is given in the book. 3 lone pair and 2 bond pair. 3 lone pair and 2 bond pair. Okay, 3 lone pair and 2 bond pair. This is a structure. Here, 2 bond pair and 3 lone pair. This is a structure. Okay, so XeF2. XeF2. Okay, so they mention here, yeah, 3 lone pair here, 3 lone pair and 2 bond. Okay, this is the structure. Now bromine pentafluoride is there. Okay, one lone pair is lying below. It's a square. It's actually octahedron. Okay, but it shows here square pyramidal structure. Okay, sulfur hexafluoride. This is what the structure, octahedral structure. Then iodine pentafluoride is there. Then xenon tetrafluoride is there. Okay, so you can see from the table, you can easily find out the structure of molecule. Okay, IF7 is there. Okay, IF7. It is a pentagonal bipyramidal. Okay, so this is what the structure over there. Then xenon pentafluoride is there. Okay, so from the table you will get the clear idea about the of molecule. What are the limitations of valence shell electron pair repulsion theory? Okay, so it cannot explain the shape of molecule having high polar bond. Then it cannot explain the shape of molecule or ions having delocalized pi electron system. It cannot explain the molecule which is have inert pair of electron. Okay, it not explain the shape of certain compounds of transition metals. Okay, it cannot explain the isoelectronic species or the elements from which a molecule are formed. Okay, so these are what the certain limitations. High limitations are there, which cannot be explained with the help of valence shell electron pair repulsion theory. Okay, after this, I will continue remaining part in the next lecture, and that will be the last lecture from your syllabus, which is belongs to me. Thank you.